Question 1. Determine if the function f of x equals x squared divided by 5 plus 7 has an inverse. So the first thing we're going to do is we're going to write this in xy form. So we'll replace f of x with y. So y equals x squared divided by 5 plus 7. Now when we're looking for an inverse, what we're going to do is we're going to swap the x and the y. And then we're going to solve for y. So we'll replace y with x. And we'll replace x with y, giving us x equals y squared divided by 5 plus 7. And now we're just going to solve for y here. Oh, sorry, this is not over 5. This is just 7. So we're going to subtract 7 from both sides, right? We're just trying to isolate the y term. This gives us x minus 7 equals y squared divided by 5. Now we're going to multiply both sides by 5 to cancel these terms, which gives us, when we distribute through, this gives us 5x minus 5 times negative 7 is negative 35 equals y squared. I'm going to move this to the front, to the other side, so that it's just sort of easier to look at. So I'll just rewrite this as y squared equals 5x minus 35. We'll bring this all up here. And we're going to take the square root of both sides. So just to show you. That's a weird 5. I'm just going to fix that. Take the square root of both sides, right? The square and the square root will cancel, and we're left with y is equal to the square root of 5x minus 35. Now, the problem here is that we can have a positive or negative for the square root here, right? We don't know whether this is going to be positive or negative. Either will work. And so what we end up with on a graph is something that looks like this for the positive value and this for the negative value. One thing you might know about functions is that you can only have one y value per x value. So if we have an x value here, we have two y values, right? We have a positive value here and a negative value here. So this does not satisfy the definition of a function. It is a relation. And so because this does not satisfy the definition of a function, we know that this function right here does not have an inverse. Question 2. Find the magnitude of the vectors a equals negative 4, 3, and b equals 7, 2. So the first thing I want to do is I want to show you what a vector kind of looks like, right? We'll go with b, right? Because that's in the positive direction. So we have the origin here, right? And we're going to map out an x direction and a y direction, right? So we have 1, 2, 3, 4, 5, 6, 7. 7 to the right, 7 in the positive direction, and 1, 2, 2 in the positive y direction. Right? I'll map out some more coordinates. So we're going to move over here, right? And we're also going to move up here. And this point is where our vector points to. So we're going to have a line that goes in this direction, and it's going to be straight. And this is going to be our vector right here. So this represents b. Now, the reason this is important is because in order to get the length of the vector, we need to use the Pythagorean Theorem, which says that a squared plus b squared equals c squared for 3 sides of a triangle, where this side is a, this side is b, and this side is c, right? So we're looking for the hypotenuse of a triangle. We can use the Pythagorean Theorem to solve for it. So I guess since we described b here, we'll start with b. We have that b is equal to 7, 2. And so we're simply going to plug in the coordinates. If we're looking for the side c, which is the length of this b vector, we're going to have c squared is equal to a squared, or a squared, which is 2 squared, plus b squared, which is 7 squared. And now if we're trying to solve for c, we want to take the square root of both sides. The square and the square root will cancel, and we'll be left with c is equal to the square root of the square of 2, which is 4, plus the square of 7, which is 49. So this will be equal to the square root of 53. And this is going to be the length of the vector b, or the magnitude of the vector b. Length and magnitude are the same thing. I guess we'll do a up here. I'll just carve out a little space. So we have the vector a is equal to -4, 3. Now again, just in order to find the length of it, what we're going to do is we're going to plug it into the Pythagorean theorem. Take the square root of both sides to find c. This cancels with the square. We're left with c is equal to the square root of -4 squared is 16, plus 3 squared is 9, which is equal to the square root of 25, which is equal to 5. So the length of a sometimes is written like this, with these double value signs, is 5. And that's the answer to the question. Question 3. Simplify the polynomial 12x to the 5th minus 5x to the 3rd plus x squared minus 22, all divided by x squared. So in order to solve this, the first thing we want to do is we want to rewrite each term being divided individually by the term that's dividing all of them. So 12x to the 5th divided by x squared minus 5x cubed divided by x squared plus x squared over x squared minus 22 over x squared. The reason for doing this is that it becomes very obvious what we're supposed to be dividing by which term. So you can do this if there are more, if we had, say, 3x cubed, then you would just write, plus 3x cubed down here alongside the x squared. But then it becomes a little more complicated. We actually have to do synthetic division or polynomial division. With this, because we're just dividing term by term, a single term divided by a single term, we can simply divide out these values. So remember that when we're dividing, let's say a over b, a to the c, right? With the same base, basically. When we're doing something like this, what we're really doing is a to the b minus c. We want to subtract the exponents if they have the same base, right? So for this, since we have an x in the numerator and an x in the denominator, we just subtract their exponents. So we have 12x, 5 minus 2 is 3, so 12x to the 3rd, minus, for this one, we have an x to the 3rd and an x squared, so we have 5x. We can put a 1 there if we want to, or we can just leave it, plus x squared divided by x squared. If you divide something by itself, it just gives you 1, so this is plus 1. And then for this, there's nothing we can do to this term to simplify it any further, so we just write minus 22 divided by x squared. And this is our final answer for the simplification process.